Yeah, he's getting better. He wishes he was here. I wish he was here. We've had a lot of plans for what we wanted to do these 2 days, but we've salvaged what we can. And this is a talk we put together to do as a duet. But now that it's just me doing it, I get to do a few things differently. And one of the stories I like to tell is just like, folks talk about getting involved with computers. My first microcomputer was a TRS-80 Model 1, 4K of RAM, 1977. And it had a version of BASIC not built by Microsoft. It was actually a small BASIC, and it only had 3 error messages. What? How? Sorry. Which I still think are some of the best error messages ever, because they're really honest. I mean, what is object not found but sorry? The only difference is back then, with only 4K of RAM, everything's just command line. You're going print divide 1 by 0, sorry. What do we do now? Windows makes you agree that you're wrong. Registry is corrupt. Okay. There's no not okay button. In fact, you can't do anything until you agree your registry is corrupt. Sorry. Let's talk a little bit about the personal computer. And if you've not been under a rock for the past 10 years, you know that the personal computer is in decline. Here is the great graph, and it shows that in 2011, that was the peak sales of the personal computer at about 365 million units, and it has declined ever since, and we're all doomed. Now, here's what annoys me about this number. Why is this a personal computer and this is not? Really? I mean, this computer is so personal, I'm afraid it's going to give me cancer. I keep it in my pocket all of the time. I wear a Bluetooth headset so I can get brain cancer and testicular cancer at the same time. That's a pretty personal computer. But it really speaks to a larger thing, right? We call it a smartphone, but it is just an evolution of the computer. Moore's law is still in action. We're taking the same computing power that used to be in a beige box and shrinking it down to a smaller device and a smaller device, new form factors, new places that we can put it, and it opens up a door to even more possibilities. Now, a way to demonstrate Moore's law is to look at some machinery. For example, this thing. What is this? Warp drive from Star Wars? Star Trek? No, that's a warp drive. This is a Cray 2. So 1985, this is the leading edge of computing. This is the most powerful supercomputer in the world at 1.9 gigaflops. And it cost $16 million in 1985 dollars. It's cooled by mineral oil, because it ran so hot it couldn't be air cooled, and consumed something like 200 kilowatts of electricity. Now you fast forward 26 years to 2011, this is the iPad 2, $800. Do not bring anywhere near liquid. Also 1.9 gigaflops of processing power. And with the Cray modeled nuclear explosion, this thing plays Candy Crush. But the same amount of horsepower. And so it's an interesting lens to look at and say, what's the most powerful things we have today? What's our potential computing, and how is Moore's law going to apply going that forward? And realize this is a 2011 device, and even when it was made, not extraordinarily fast. There is more speed to be had. If you've got $1,500 US, bring a hole in the pocket, you can spend that on a video card, right? That's a Titan X video card that runs somewhere in the neighborhood of 7 teraflops, 3,500 times faster than that Cray 2. Moore's law continues. And if you really want a big machine, here's the largest computer in the world at this particular moment. This is China's Tianhe 2, $400 million, for 34 petaflops. That's a lot of flops. There's an argument that the human brain does about 25 petaflops, and so this is the first machine built that in theory is faster than the human brain. I'm sure it has software issues. Right? Just, now it goes very quickly. And if you're doing the math, that makes this thing 17 million times faster than the iPad, and interesting, both built in China. So what are we learning when we think about how Moore's law applies to this? We are still in a continuum. This is not the end of the road for devices, for what the personal computer is going to look like. We already see more horsepower, more potential. Moore's law is applied in a lot of different ways. I can reduce power consumption, I can reduce size, I can increase compute for the same amount of money, for the same amount of space. And that combination is really interesting. But what does it mean for us as developers? We had a nice little window for a number of years where the computer that we wrote our software on is the computer that people ran our software on. And that is simply not true anymore today. The majority of your consumer users are using these to connect to the internet, to surf the web, to talk to your customers, to talk to your companies. And it's very hard to write software on this. You write your software on a much more traditional looking PC, and then you have to make it run on these smaller devices. And that's going to continue. That's going to evolve further. And it raises a level of complexity in the way we've built software up until now. That the device that our customer uses is not the device that we're using. And it makes you pine for simpler days, right? We should have the theme song playing here. Anyway, back then we had diversity too, right? You had a choice between Windows 98 or Windows 2000, right? That was diversity 15 years ago. Life is pretty easy. The machine's all about the same. They work the same way. And we had this very odd time where it was all the same platform. It was all the same programming. Like, things were pretty simple in the way to work. But it wasn't like that before this time, and it isn't like that now. The anomaly is that Wintel-dominated time. If you go back before it, you get into earlier computers like the Apple II, the 64, the original Macintosh, 1984, and the IBM PC, 1982. This was the competitive landscape of the personal computer in the 80s. It all had different operating systems, and people were deciding, do I want to buy a computer? And the very first program that anybody really cared about in that space were the spreadsheet, right? Dan Bricklin, actually on the Apple II with a program called VisiCalc. But when I look at this diversity of machines, it doesn't, for me, feel all that different from this diversity of machines. They're all actually personal computers. They have different operating systems, and we have the same basic problem. I want to write my code once and run it on all of them. That's what I want to do. It turns out my customer doesn't care about that at all. They only care that my program runs on their device. That whole write once, run everywhere thing, that's something we want, not necessarily what they want. And it's not the first time that we've tackled this particular problem. Let me tell you a story about a product called Multiplan. Now, if you look closely at this picture, this is a photograph of an actual packaged box of software that once sat on a shelf. Note that it is for the Apple Macintosh. It's also $325 US. When's the last time you spent that much on software? And this was Microsoft's original spreadsheet program. And it was the brainchild of a man named Charles Simonez. He's a Hungarian PhD computer science guy, worked at Microsoft. He's also responsible for Hungarian notation. And he had built an engine to allow Microsoft to program in C and cross-compile to all of the popular PCs of the time. And so Multiplan was available for the CBM 8032, for the Mac, for the PC, and so forth. Powerful stuff. Write once, run everywhere. And the result was that Multiplan ran equally slowly on all of those machines. And a rival turned up. Anybody remember the rival? Lotus 123. And Lotus 123 ran only on the IBM PC, and it was tailored to run on the IBM PC, and it ran fast. And people trying to decide what computer to buy, and they recognized the spreadsheet. The spreadsheet was the first program that regular mortals understood on a computer. Now a computer was useful. It's ledger paper that adds itself up. That's cool. I want me some of that. And so they chose the IBM PC and Lotus 123, which went on to dominate the industry at the time and gave us an object lesson in, if you make big sacrifices to do cross-platform development, somebody can scoop up your lunch. The sacrifices matter. Now, what happened to Multiplan is that Microsoft went back into the lab to try and make it better, and they re-released it initially for the Mac as a product we know as Excel. So they all have a common origin, and that is the pattern that repeats over and over again. You try and make things better. Now, we've gone on to do more write once, run everywhere solutions, right? Folks remember Java, right? Some of us called it the write once, debug everywhere. There's a bunch of challenges there. It had a good intent, one language, many platforms. It's interesting to look at where .NET is today. Remember when this was any language, one platform? It's not like that anymore. We also had Silverlight, and Silverlight also offered up this, and I see some pain faces right now. It was a fun time. You know, the thing we forget about with Silverlight was there were pieces of the CLR that ran on the Mac. Back before anybody, we never really talked about that part. The fact that you could write something in C# and XAML and compile it in Silverlight and then run it through a browser and it ran on a Mac as well meant there was pieces of .NET framework way back then, being 6 years ago, okay, that ran on the Mac then. Now, Microsoft didn't kill Silverlight, Steve Jobs did, right? Now, for a good reason, in 2009, the iPad comes out, and actually, I don't think Jobs even knew about Silverlight. I don't think he cared about Silverlight. He cared about Flash. And Flash was making his iPad look bad because Flash is evil. And so he banned the add-in on the iPad. The Safari browser would not allow add-ins, and Silverlight was just a casualty of that. You couldn't write in Silverlight and expect it to run on an iPad. Totally reasonable thing, for better or worse. There's a bunch of advantages to not having add-ins, besides the fact that it can actually cripple your machine, eat up a lot of processor and battery. It's also a great malware vector. So, you know, they made some good decisions here, but losing Silverlight, I think, hurt a lot of people. We really were enjoying that development model, and it just sort of died abruptly. And I'm not that Silverlight actually mysteriously stopped working. You can still build Silverlight apps if you want. Microsoft even has guidance around that. They're really intended for internal applications. Now, if you want to do cross-platform development with today's tools, the logical choice is JavaScript, HTML5, CSS3, right? Which really means you're writing for the browser. So as long as it runs in Chrome, everything's okay. What, those other browsers? That's just crazy talk. And it's interesting to think about that same device that killed Silverlight, the iPad, and its weird version of Safari, because Safari is now the new IE6. Now, stick with me on this, because sometimes people say that's very, inappropriate. But what was wrong with IE6? It was not compliant with current standards, and it was very popular. Look, if you have something that isn't compliant with standards, nobody uses it, doesn't matter all that much. If it complies with standards and is popular, that's fine too. But when you have something that isn't compliant with standards and popular, it makes web developers' life hard. And that's what Safari is doing right now. It is not up to standards. Certain things don't behave right, and so you're now seeing web developers in the same situation. You've got to make a page that runs in one way for most people and something for Safari. If you can convince an iPad user to install Chrome on your device, awesome. Then you can make all of that work. But this is our current cross-platform solution. This is the greatest. We all need this mug. You have a friend who should own this mug. Let's talk a little bit about responsive web design, because that's the approach in HTML5 JavaScript to allow us to deal with these different form factors. And I think it's mature enough today that we can trust it, that things work. The .NET Rocks site now runs in a responsive design so that you have one page that works on your phone, on your tablet, on your PC, right? Or renders poorly on all three, whatever makes you happy. You work either way. The challenge, of course, is actually making this work. And folks who've done it know everything to test. You have to check on all the different pieces of hardware, so what that looks like. And that leads to this thing that we talked about on the show called the drawer of broken dreams. So what's in the drawer of broken dreams? Why, many devices. Let's just worry about phones. In fact, let's just worry about Android phones. We'll pick a simple segment. So you start with a popular Android phone. Let's take Samsung's S6. You've built your initial page, you fire it up on the S, doesn't look quite right. You do some tweaks to your CSS, typically, to get it to render nicely on the S6. One down. You go back to the drawer of broken dreams and you take out the next phone. It's going to be a Nexus 5. That's a popular phone. It's not going to render right. You do a few tweaks, get it rendered right on the 5, then you're going to go check it on the 6 and find out you broke it. Tinker with it, get it work on 2 phones, and then you go back to the drawer of broken dreams, don't you? How many phones are in the drawer of broken dreams? If you want to get to 80% of the Android market, it's about 100 phones. If you want to get to 100% of the Android market, like your boss asked you to, it's about 10,000 phones. So, ouch. Now, there are solutions to this problem. There are organizations that have gone out and made the biggest drawer of broken dreams you've ever seen, right? Amazon's Test Cloud, Xamarin's Test Suite, where they literally have every device you can think of lined up, and for a fee, you can fire your site onto them, and they will give you video of your pages rendering on each of those devices. It costs enough that you're not going to do it in every iteration. It's going to be one of those things where you're going to build a whole bunch of code into that, and then you're going to look at all of these attempts of rendering, but it is an interesting challenge to make this work. And that's, so far I've just talked about web. Let's talk about native. So 3 approaches, and this is where Carl would make more sense, because obviously Objective-C and Java, we know those are for. That last thing there for guitar players is a C#. Yeah. So what's wrong with native development? Nothing, right? Except that each of these platforms are quite different from each other. They're different sets of skills. It is very hard to keep all these skills in your head. If you're trying to reach a broad audience, you have to write a lot of code. If you want to reach out, I mean, this is where Apple's walled garden approach and forcing everybody to upgrade is good for developers, because odds are you only have to build for the latest version of iOS. That's pretty straight up. And Swift is a much nicer language as you could ever hope to be. A little more challenging in the Android space, because you have that diversity of devices, you have that uncertainty, can be challenging to actually get it to work on all the devices. And C# up there because we like it, not because you can build anything on a device that actually matters. And I hope there's no Finns in the room, because I'm sorry, Microsoft did it again. So let's talk about Xamarin. The Xamarin story just got really, really interesting. So Miguel Diaz and the boys decided to write their own version of C#, although now they've a Project Rosalind, that's now able to compile, use C# to compile onto iOS and Android. And one of the biggest discussion points we've had on the show over the past few years is how this abstraction absorbs a lot of variation for Android devices, that it's actually easier to make more Android devices work writing on the Xamarin stack than it is writing natively, which is very interesting. And if you watch the build keynote, they showed seeing an iOS client on your Windows PC. It's a little bit more mature, and so people are having more success with it. The universal app model is supposed to take all of this over. So they're trying to consolidate this into one coherent message. And that sort of leads us to a conversation a little bit about Win 10. We're all running Win 10, yes? Mostly, okay. This machine runs Win 10, mostly. Few things that came with Windows 10. There's the Edge browser. Fairly frustrated with the Edge browser. If you're a web guy like me and you ever look at the user agent on the web browser, the user agent says, I'm everything. Like, if you're writing a web page and you're kind of, figuring out which browser you want to use, you will usually interrogate the user agent. You'll say, are you WebKit? Meaning you're Safari. Okay, well then we'll go from there. Are you Chrome? Are you Gecko? And so forth. Well, every one of those words is in the Edge user agent. It is everything. It just wants to render your page, please. So, and of course, it doesn't have an added model, although that is now changing. So we're looking to what Edge will ultimately look like. But the reboot of the browser on the Microsoft side, interesting. The other big piece is Cortana, and I think you've heard a few things this past couple of days about speech is coming true. We're finally getting to a place where that's actually going to work, where it's a different way to think about a user interface entirely, and it's being given away. It's just an SDK. You can utilize it. It depends on the cloud. The universal app is becoming a bit more true. Microsoft made several incarnations of different things they called universal apps for quite a while. I remember the old 1 foot, 3 foot, 10 foot experience. A universal app actually makes that possible, that I could write a one code base, runs on a phone, runs on a PC, runs on an Xbox One. The Surface Hub, which is kind of a mythological thing for most folks. I've seen a few in person. The problem is that Microsoft's backordered for these for more than a year now. They're selling like hotcakes, really are. And it's an interesting way to think about software. Think of a Surface Hub more like a projector in a room. It's not a personal device, it's a room device that gives you the ability to move data onto it, manipulate it with multiple people, and then move off of it again. So it's an impersonal PC, because it's not you, it's not yours. It's for everybody to use temporarily in a workspace. And this app model allows us to build for all of those things. And of course, HoloLens. And how many folks are going to go see Laurent later on and see his HoloLens in action? I mean, I'm excited that Microsoft's taking on the hard problem of augmented reality as opposed to virtual reality. They're very different things, although they tend to be spoken side by side. But this ability to see the world and then add information for you, that's very interesting to me. This device has a ways to go in terms of, is this going to be a consumer level device? How good will the production unit be? We're still very much in the SDK stage. There's a lot to be done here. I do have a sense that this kind of product, the visor type product, is the only thing that will unseat the smartphone as the principal personal device. I don't know, it's this version of it, right? And the problem is that up till now, every time you put something on your face, people just make fun of you, right? Just ask anybody who was crazy enough to buy a Google Glass. Nobody wants to be a glass hole. But if you think back to before the iPhone, before every phone looked like this, phones were different. They not only had different styling, different look, and the way that you handled them, but you also did it a bit more privately. You know, the walking down the street in front of a bus behavior is a relatively recent behavior, or there'd be a lot fewer humans. Because it was so compelling, what was on this device, that you didn't care that you were being rude. And now it's become socially acceptable. The visor will get there. The glass was not compelling enough. This might be the device that's compelling enough that, yeah, okay, I look like a dork, I don't care. And once we all look like dorks, none of us care. Right? That's how these things ultimately get adopted. And I think it's the first device I've seen where finally putting it on your face is not a showstopper. If you get some time with this machine, you're going to come away going, holy cow, it's kind of profound, and it speaks to an interesting future. Because I'm pretty sure this isn't it. The watches, and I'm wearing a band, I mean, they're extensions of phones. It's an even smaller form factor. It's all of the problems of shrinking with none of the benefits. Now, it's interesting to try and find a way to write some code that people care about in that space. I'm like the band better in the context that it doesn't focus on putting a lot of data on the screen. It's more about instrumenting me. This has a heart rate monitor in it. It has a pedometer in it. It has a skin galvanic sensor in it. It can tell I'm sweating. It has a UV sensor. I've had it buzz at me and said, you've been out of the sun too long. You've got sunscreen on? It's a little creepy. It's like Microsoft Mom. Where do you think you're going today? So, but you're getting to an idea of what the potential is there, of instrumenting our bodies. As these devices continue to shrink and we get more and more horsepower. And that leads to this idea of the Internet of Things. Now, this is just what happens when the PC gets fingernail sized and costs $5, but still runs .NET. You know, what's happening in appliances right now, ever since appliances went electrical only 100 years ago, they've always had custom equipment in each appliance to do the things it needed to do, right? Custom embedded gear was the way to go. All about controlling cost, reliable and simple, right? But when a Raspberry Pi Zero is $5, it's in the price range of what this embedded gear is and has a much larger development community available to it, tooling available to it. But it's a tremendous amount of horsepower available to any appliance. Yeah, I have a dishwasher with an IP address. That was weird, but when I had an iron that had an IP address, or a toaster that has an IP address, I mean, this is the path we're starting to go down, which also means we have a massive attack surface. We've got to deal with the security issue around this. And I'm sure you've seen the story of the Jeep Grand Cherokee that got hacked in the wired story and so forth, where the guy, it was all fun and games when they put up their faces on the guy's screen while he's driving down the highway, and then they turned on the fans, and they turned off the speedometer, and they put the windshield wipers on. Everybody was laughing. Then they shut off the brakes, and it just wasn't funny anymore. So, yeah, we need to address the security problem, and there's lots of people working on that particular problem. I also want to harass some back-end technology, and I put up both IIS and Apache side by side because they're very much the same product in the sense that these were the original back-end tools for making the web an application development space. And it's important to remember that Apache doesn't stand for the native Indian community. It is a pun on the fact that this particular piece of software needed a lot of updates. It was literally a Apache server. That's where the name comes from, okay? And like IIS, they're like a Swiss Army knife with every blade out. Everything you could possibly think to do in a web application, it can do, and it's already turned on, just in case. And so, for those of us who are trying to secure the web, you had to go through these products and shut stuff off. You don't need that. It doesn't need to be there. There was a whole set of tools just to get it into shape, to make it do what it was supposed to do, act the way it was supposed to act. Now, that was fine when we were new to this, but we're not new to it anymore. Now it's important in our business, and that's why you're seeing this lashback with tools like Node. Right? Node is interesting from a couple of perspectives. One is, it was one of the best manifestations that JavaScript became a real language. Right? From being a scripting language hung off the side to a browser, to that amazing time just a few years ago when the IE team and the Chrome team were dueling out their features in their browsers, and they got faster and faster and more capable, and they grew up the Chakra engine and the V8 engine, these two stunningly good JavaScript engines. This is the best kind of competition in our industry you could imagine. And those teams knew they were competing. They sent each other cakes each time they got a new version out the door. And people then took those engines, and this is where Node came from. They took that V8 engine, they said, how about we start with a blank slate when we build a back-end service, that you define each thing that you need, which is really fun the first time. And after that, you learn about templates, because building out each service by hand again and again gets very old. But it's a logical swing from what we were doing in the IIS Apache world to a much more deliberate, specific, prescriptive way of this is what my service looks like. I can test it, I can repeat it, I can scale it. Other back-end technologies that we've been very excited about, the Erlang story is really interesting, especially being in this town. You know, the Ericsson folks built a tool decades ago that continues to run the telecommunications infrastructure of the world. No two ways about it. And the WhatsApp story of a tiny company handling more messages than most telcos handle until it got acquired by Facebook, and then all crazy things happened because of Erlang. At the peak, WhatsApp had built a custom version of Linux so that they could handle 2 million connections per machine to serve WhatsApp, and they were only at 40% CPU usage when they were doing that. Erlang is insanely efficient. But if you've never dabbled in it, it's a very different way to think. This is taking functional programming to another level. It's effectively its own operating system as well. So there's a lot in there, and it digs in seriously into this idea of the actor model. And another way to get at the actor model is a library called Akka. So Akka is originally a Java product, but there is an Akka.net. And I think Roger Alsing's even here. Yeah, there's Roger back there. Take a look at what Akka does. It's extraordinary, and it allows you to run it on-premise, in the cloud, however you want to work, and it's just a different way to think about building highly resilient, highly scalable software. One other language in that space, especially in the Erlang space, is a language called Elixir. And so Elixir is literally syntactic sugar sitting on top of Erlang, making it a little more palatable, and they have a library called Phoenix, which is an MVVM library to help you build websites in Erlang if you want to get started in that. Data storage. Now look, I am a relational database guy. I first looked at the RDBMS in 1985. I watched CJ Date talk about how it was going to work and what that was all going to be about, and I have no problem with it. I'm pretty sure SQL bought me a house, just in terms of writing a lot of software over the years. But let's be honest. We abuse that database too. We put stuff in there that isn't relational to anything, because it was just, this is where you hold your stuff. And then we make DBAs responsible for not losing any of it. And that's why they look at us like that. And then they say no a lot, because they are responsible for that data, and they do have to take care of those things. And so they're careful with it, and we started working around them. The NoSQL movement came out of a few different forces. One was that it was harder and harder to get stuff built against relational databases as we demanded more and more from them. And taking that back made that easier. Mongo's got its problems, you know? We forget the tests that relational database went through to make sure the data was protected, was backed up, was recoverable, was transactionally reliable. You can get that from a non-SQL store today. You just have to take the time to understand what it is. But it also has become abundantly clear to me that when we were creating objects that were orders, and then in order to complete that order, we make the customer wait while we decompose the object into rows and columns we've written to a database, it seems a little silly. So now you're seeing a pattern where you take the object and you store it and you let the customer go on their merry way. And sometime later, being milliseconds later, we'll pick up that now safely stored object and decompose it into rows and columns in the relational database for the reporting that it's actually good at. So the combination of the two makes a lot of sense. And the fact that the licensing on most NoSQL stores is a heck of a lot friendlier than the average Microsoft SQL Server installation makes that all the easier. If you were serious about data analytics, you started building data warehouses. Data warehouses made me a lot of money too, because that was about taking huge amounts of data and organizing it in a way that you could query it quickly. The challenge here is you were doing analysis, so you were pursuing an intuition line, and so the speed mattered. And so you spent a long time pre-computing things. You had to use resources efficiently. And now we're talking about data lakes. And what is a data lake? And how do you stop it from being a data swamp? This really only makes sense in the context of the cloud. You're bringing in data, and what the data lake says basically is store it as is. Do not manipulate it in any way. Store it hierarchically in the format that it came in and just keep it. We'll charge you by the month for it, right? It's just storage. But when you need to do analysis on it, we will do that entire extract, load, transform process for you on demand. Because the neat thing about the cloud is, how much compute would you like? I would like 10,000 computers for 15 minutes, and then I'll give them all back. So I can suddenly crush massive amounts of compute pretty much on demand. And so rather than take the time to shape the data in advance and possibly shave off important things or destroy relationships, store the data in a lake, keep it as it is. And then as you have different analysis needs, you're able to pick it up and run with it. The whole big data story, and it's not about the size, it's not even about the technology, but it's about this idea that we are interested in the broader relationships in our data. This is an opportunity space that's still not really been executed on well. You'll see some wins for various people, but we're going further down the path. We're getting better and better at doing that. And again, the cloud is playing a huge role in this. The more interesting aspect that gets sort of beyond the big data concept is the idea of machine learning. We called it data mining back 20 years ago, and it was the realm of the data scientists and folks that thought statistics were fun, right? And they would start doing analysis on data, and you'd have to plan very carefully because the compute resources were rare and expensive. Storage mattered. All those things aren't true anymore. We have the cloud. We have as much compute as we want. We have as much storage as we want. So suddenly you can do machine learning kind of brute force. There's about 16 or 20 different ways, different kinds of algorithms for analyzing the relationships in data. And you can pretty much point at the machine learning tools in Azure and say, see all this data, find me correlations. Try all of the algorithms. You have 20 minutes. And it just fires up enough resources to crush through all of that data and get you back results. So you really can do this in kind of an experimental way. You know, I remember doing analysis like this in the early aughts where we'd leave the compute run overnight. And the next morning I'd look at it and go, okay, well, we made a mistake, make a couple of changes here, run it again for another night. And it literally was a day for each test. And now it can be minutes. Predictive analytics, the PA part of that, is a subset of machine learning that is the more, when you're trying to introduce this to your employer or introduce this to your customer, PA is the one that most people get. Machine learning allows us to look back into existing data and understand that their trends have happened. Predictive analytics takes that same result and said, let's look forward and say, what's the sales going to look like the week before Christmas next year? And that gets a lot of people excited. right? You can model on an awful lot of information for that. It's an interesting way to spend your time, and it's an opportunity space that's quite large. I would be remiss if I didn't talk a little bit about containers, because these are going to come down on us in a big way this year. So Server 2016 is going to be the container edition. There's many other things in Server 2016. It's another one of these big leap versions of Windows, which is going to have impact for us as developers. But containers are important. Containers are important from the perspective that this is the virtual machine without the operating system in it, done in a configuration as code way, so that you can declaratively design your container on the fly. It's literally an executed chunk of code that says, you got to run against this OS, here's the configuration settings you want, here are the tools that are put in, and you step into a tool like NuGet and Chocolatey to actually completely configure a machine. But because each one of them is lighter weight, you no longer need a Dellosaurus to do development. Right? You know those giant, Lenovo makes a giant laptop, Dell makes a giant laptop, right? The kind that can heat a building. The one that has 32 gigs of RAM in it because you're running 4 servers inside your laptop. And if you are, you're probably a SharePoint developer. But you needed each of those VMs because you're trying to run an environment that looks like production, which makes sense. There's a whole class of errors that don't happen to you when you can run in that kind of shape. Containers allows us to do this with a lot less resource, so that we can have a container for our data store and a container for our web services and so on, run them inside of our machine, but they're actually organized the same way they will be in production, and they're validatable. They're built from a script. So when you want to compare your version of the containers to my version of the containers, it's a string compare, right? We're just matching documents. That's pretty painless. It keeps a lot of problems. Docker is obviously the popular brand in the space, but it's not the only one. Right? There's Mesosphere, there's a half a dozen of them, and Microsoft's working with most of those folks. One true cloud, and this is my only Microsoft slide in this whole thing, one true cloud product that I find interesting in this space is Azure Service Fabric. And here's why. We've done several shows on this now. We've realized that we're making our back-end services too large, right? That is the, quote, microservice movement, that we're having problems updating services. They get a little bit monolithic and confusing, and so we're breaking them down into smaller pieces. And we're using container technology in some respects to keep them in smaller containers. They're easier to deploy out, easier to scale, easier to build new versions. What Microsoft's done with Service Fabric is they said, what if I just gave you services that would help you do all of those things? So that you don't actually need to own the container. I mean, owning the container is pretty much like owning the VM, right? It'll work, but you're kind of responsible for a bunch of stuff that's kind of plumbing-ish. You may not want to do that. We really want to deal with the platform. And so here's an approach where it's completely platform-centric. The most compelling thing I think about Service Fabric here in this scenario is the fact that you don't have to run it in Azure if you don't want to. There's an SDK version that you install on your own machines. If you're weird enough, you can set up VMs in Amazon and run them over there. So suddenly we have a set of tools designed to build highly scalable, highly reliable services that we can run on-prem, in the cloud, on other clouds if we want, using the same tool set each time with very much a platform mindset. This is still coming true, right? There are pieces of this that are still being built. We're watching it very closely because I think it has a very compelling viewpoint for what we want software to look like. Now, I know we've raced through a lot of stuff. This is taking on literally the 1,300 episodes of .NET Rocks we've made over the past 14 years and capping them into the sort of highlights of our favorite bits of what we're most excited about. And so it's easy to kind of not only feel overwhelmed, but to sort of sit back and go, well, that doesn't necessarily apply to me. It doesn't make sense for me to go in that particular path. And I'm coming on my 40th year of writing software, right? It's next year. I wrote my first line of code in 1977. That wasn't the important thing to have in 1977. The important thing was Star Wars came out, but I have scars. They're experiences, right? Stuff I've done with software that burned me in one way or another. I became a presenter because I really wanted to save you the pain that I already had. I'm not that smart, I just screwed up first. And I would have you not go through that particular experience. But the other thing I've come to realize is that sometimes those scars hold us back from trying some new things. Last year, we interviewed a 23-year-old girl named Heather Downing at a conference in Nebraska. And she was going to college and hated her career path and did like a 20-week web course, fell in love with web development, started building mobile apps. She had a resume, she had a portfolio this big already, and was utterly fearless because she didn't know enough to be afraid. And by the way, I saw her again for the first time in 2 years just a couple of weeks ago, and still crazy, reckless, but building a lot of software. And it made me think, as the old experienced guy, where am I stopping trying some of these things because of an experience I had 20 years ago that said, there be dragons? Because there might not be dragons over there anymore. So I would ask you, as I whip through this huge stack of stuff and say, look at this and try these different things on, make sure it isn't your experience that's stopping you from trying it. Take those experiences and say, validate stuff. You don't store everything in a relational database because a relational database is the best way to store stuff. That's not true. But relational databases went through a gauntlet, that acid validation, that we know for sure that data is safe. Take that knowledge and apply it to a different kind of data store. If I know my data is safe, why wouldn't I use this other store? So you can use your experience as an asset to exploring new technology. But I'm more concerned that we use it as a crutch to not try these new things. We're moving very fast in this industry, and there's a lot of stuff to do. And so with that, go out and write some code. Thank you.